Hey guys, I'm Miss Peterson, and today I'm going to talk to you about two really awesome demonstrations that I have for you guys. I did want to go ahead and do this introduction video because while I'm doing the actual demonstrations, it's going to be more focused on the table and the activity itself rather than my face. Sorry, I know. I do miss you guys so much, and today I'm going to talk about two things that we really enjoy talking about. One is the rock cycle, and we'll be doing that with Starburst. This is also something that you can do at home, and as a bonus, you get to eat the Starburst when you're finished. And the next thing we're going to talk about is plate tectonics, and we'll also be doing that with a few stranger combination of snacks, although I've seen you guys eat some pretty strange things, so you might enjoy that one too. All right, so this demonstration is going to represent the rock cycle, and I have used 3 different color Starburst here so that you can easily see kind of what goes on in every stage of the process of the rock cycle, and also it's kind of something fun that you could do at home if you'd like to try it as well. So what I did at first, I took 3 different color Starburst and I melted them down for our magma. And then I let that sit and solidify, and that became our igneous rock. Now, this igneous rock can be weathered and eroded and broken off into sediments. And each of these little sediments can eventually come back together as they have been deposited through different areas, and they will become cemented together and form your sedimentary rock. Now, we spoke about sedimentary rocks, and what's so cool about these types of rocks is that they're the only ones that can actually hold fossils. And that's important as we go on to talk about the geologic time scale and the history of Earth, because that's how we know how old all living things on Earth actually are, is because we found these fossils in these specific types of rocks. So here again, we have our sedimentary rocks, and you can see the little sediments that have been compacted together pretty firmly to make that second kind of rock. Now, with that sedimentary rock, which I have some extra sediments here that I wanted to use. So let's say we make our sedimentary rock with these, more colorful so we can see them. All right, so we've compacted that sedimentary rock. Now, in order to make it a metamorphic rock, which we've talked about, you have to apply pressure as well as heat. So I have this plastic wrap here to help me with the heat aspect. And the pressure, I'm just gonna mold it kind of like Play-Doh with my hands. And again, this is something you can easily do at home, especially as you're working through that worksheet and you need kind of a visual representation, because even though I know you didn't throw out all your notes from this year, it is nice to have a little visual representation as well. So you can easily do this at home as you're going through those worksheets if you need a little reminder, just a little review of what's going on here. So I'm gonna unwrap this, and you will see we have a brand new, very marbled looking metamorphic rock. And again, if you take this metamorphic rock and you melt it, it goes back to our magma. That magma can also solidify back again into our igneous rock, and that's the rock cycle. All right, for this demonstration, we're going to talk about the tectonic plates, which we mentioned in the third 9 weeks. All you need for this demonstration, and trust me, you're going to want to do it at home because it's super awesome and it tastes really good. All you're going to need is some icing. I chose chocolate because everybody loves chocolate. Graham crackers and fruit roll-ups. So as you remember, the tectonic plates actually live in between the mantle and the crust, right on top of the asthenosphere, actually on the lithosphere. That's where your tectonic plates are. Now, when we're talking about the tectonic plates, there are 2 main kinds of tectonic plates. You have your continental plates, which are stronger and more dense, and your oceanic plates, which are less dense and they are weaker. So what happens when you have your 2 strong continental plates at a convergent plate boundary, which means they come together? As they push together, you can see kind of that icing coming up. That's actually showing you how those mountains are formed when we talked about in class, those 2 plates pushing together, pushing up that magma up into the surface and causing that mountain to form. Now, what happens, smooth that out a little bit, when you have one continental plate and one weak oceanic plate. Now we talked about this in class, so if you don't remember, this one takes a little more effort on your part to make sure it goes well because that's a lot of icing. But what's going to happen is that weak oceanic plate is actually going to subduct and be pushed under that strong continental plate, and it's going to form some sort of a ridge. Now, what happens when you have, I'm gonna put a little more icing there, when you have one oceanic plate and another oceanic plate at a divergent plate boundary, which means they separate. Now they're separating, so what is in between them, that magma from Earth's mantle is going to push up. And because it is at the bottom of the ocean, it's actually going to solidify and form a mid-ocean ridge, which you can kind of see here. Also from the force of those plates being pushed away, you can see it actually pushed open a ridge at the bottom of the ocean. Now, it is super, super messy, but it is awesome, and I wouldn't recommend eating this part. But these are not so bad, and it's pretty fun.